Hello students, welcome to mathematics class. Students, this is part 1 of the chapter playing with numbers. In this part 1, we will learn numbers in general form, games with some numbers and letters for digits. Students, coming to the numbers in general form. Suppose if I am given a number 35, it is a 2-digit number. Do you think 35 is nothing but 3 into 5 or 3 plus 5, or do we have any operation in between 3 and 5? You know, numbers are formed using numerals from 0 to 9. So, there are 10 numerals forming these numbers. Here 3 and 5 are in fact formed a 2-digit number where usually 35 is nothing but that there are 3 tens and 5 ones. If we write this way, that is, how many tens are there and how many ones are there, we call them as expanded form. You know, this expanded form is written by writing the given number as the sum of product of the digit or a numeral along with its place. You know, it is in the place of tens, so place value of it we are writing as 10 into 3, and 5 is in the place of units, so we are writing it as 1 into 5. This expanded form of 35 is called generalized form. Okay, it is the other way called generalized form or general form. So, remember, usual form of number 35 is actually means 10 into 3 plus 1 into 5, which we called as expanded form or generalized form. So, this is generalized form of 35. Next, coming to the next number 69, this is another 2-digit number where number of tens are 6 and number of ones are 9. So, if you write generalized form of 69, we can write it as 10 into 6 plus 1 into 9. Whereas, we have got 0 to 9, any one numeral occupying those places, that is either units or tens. Suppose I have a number 2-digit number given as AB. What do you mean by this AB? Here A is any one of the numerals from 0 to 9. That means this A is any one of the digits from 0 to 9 will be here written in the tens place. If I am asked to write the generalized form of AB, it is not A into B, it is nothing but 10 into A plus 1 into B. This is the generalized form. Normally, we write this as 10A plus B. We have seen such things while learning linear equations chapter. Okay. Moving on to the another 2-digit number BA. If you are asked to write in generalized form, I will write it as 10 into B, because B is there in tens place, plus 1 into A, which is nothing but 10B plus A. So, you should remember AB does not mean that A into B. When AB is a 2-digit number, it means 10 times A plus B, okay, 1 time B. So, 1 time B is straight away written or just written as B, okay. So, moving on to the general form of 3-digit number. You know, this 3-digit number 485 is nothing but 4 is in the place of hundreds. So, there are 4 hundreds, and 8 is in the place of tens, that means there are 8 tens, and 5 is in the place of units, which means there are 5 ones. Similarly, write the general form of 693. 693 is nothing but there are 6 hundreds, 9 tens, and 3 ones. So, we write it as 100 into 6 plus 10 into 9 plus 1 into 3. And similarly, if you are given instead of numerals 0 to 9 some letters like A, B, C occupying the tens place, hundreds place as well as units place, how do you write it in generalized form? So, generalized form of ABC 3-digit number is 100 into A plus 10 into B plus 1 into C, which is just nothing but 100A plus 10B plus C. Similarly, what is the generalized form of 3-digit number? CAB, where C is hundreds place, A is in tens place, and B is in units place. So, its generalized form is 100C, 10 times A and 1 time B, and their summation is 100C plus 10A and plus B. Can you write now generalized form of DAC 3-digit number? Definitely it is. Straight away we can write 100B, 10A and C. So, 100B plus 10A plus C will be the generalized form of this 3-digit number BAC. Okay. Now, let us answer some questions. Write the following numbers in generalized form. So, what is the generalized form of 73? It is 10 into 7 plus 1 into 3. Now, what is the generalized form of 129 3-digit number? 1 into 100, 2 into, or I can write here instead of 100 into 1 plus 10 into 2 plus 1 into 9. Now, this is the generalized form of both the 2-digit number as well as 3-digit number given. Now, moving on to the another question. Write the following numbers in usual form. Usual form is this. 73 is a usual form. Normally we write 2-digit number. 129 is a usual form of this expanded form. So, here watch this expanded form. 100 into 7 plus 10 into 1 plus 8. So, there are 700s, there are 1 tens, and there is 1 units place 8. So, 718 is usual form of given this expanded form or generalized form. Here 100 into A plus 10 into C plus B, where nothing but A, C, B. In hundreds place A is there, in tens place C is there, in units place B is there. So, the generalized form is defined as the general form of a number is obtained by adding the product of the digits with their place values, I think here it is their, with their place values. Now, you know the general form of a 2-digit number is, if I take AB as a 2-digit number, then 10A plus B. The general form of 3-digit number, if I take it as ABC, then it is 100A plus 10B plus C. Now, we will move on to the another important topic called games with numbers. Reversing the digits. Suppose you wanted to reversing the digits of 2-digit number, what would be the tricks behind that? The trick to divide by 11. We have any 2-digit number, then we will always get the remainder 0 if we add the original number with its reverse number and divide it by 11. The trick behind this is, step 1, let us choose any 2-digit number such as AB. You know it can be expanded as 10A plus B. Now, after reversing the number, we get BA, it is nothing but 10B plus A. Now, if you do the sum of both, we get 10A plus B added to 10B plus A, 10A added to 1A gives 11A, 10B added to 1B gives 11B. Here 11A plus 11B can be written as 11 times of A plus B by taking 11 common. Now, if you divide this number by 11, you will get the sum of digits as the quotient, and definitely here the remainder is 0. Okay, this number is definitely divisible by 11, you understood. So, a number added to reverse of its digits will always be divisible by 11. It is because of this reason. Okay. Now, this shows that the remainder will always be 0 in case of any number. So, the quotient is sum of digits, which is the sum of the digits of the given number AB. For example, try for the number 78. Now, you reverse the number, the given number is 78, reversing number is 87, their sum is 165, where 165 is the product of 11 and 15. So, 165 is product of 11 and 15, that is sum of digits 7 and 8 gives you 15. Okay. Now, moving on to the trick to divide by 9. So, the trick to divide by 9 is, if any 2-digit number we have, then we will always get the remainder 0 if we subtract the original number with its reverse number and divide it by 9. It is just simple because we are having a 2-digit number AB, that is 10A plus B, reverse is BA, that is 10B plus A. Their difference, if you take their difference, you know 10A plus B is original number and 10B plus A is reverse of the number, and their difference, that is this difference, if you take, you watch it, 10A minus A gives you 9A, and here B minus 10B gives minus 9B, and 9 taken as common, 9 times of A minus B, that means this number is divisible by 9, gives the quotient A minus B, right, and remainder is 0 only. So, we know that their difference is 9 times of a minus b, and that 9 times of a minus b is divisible by 9 and giving the quotient as a minus b, and this shows that remainder will always be 0 in this case of any number. So, we will check with the 78 only, we will try for the 78, reverse of it is given number is 78 and reverse of the number is 87, and their difference is 9 and 9 is divisible by 9, and where 1 is the difference between these two digits. Okay, remainder is 0 only. Now, reversing the digits for 3 digit numbers. Let us look for 3 digit numbers sake reversing. The trick by 99 now. It is so simple. Why? Because see, 3 digit number, if I consider ABC, it is 100A plus 10B plus C, and reversing is C B A, that means 100C plus 10B and plus A, and their difference will give us 99A because 100A minus A, C minus 100C gives you 99C, and which can be written as 99 times of A minus C. Now watch it, how it is going to come. Here, if we have any 3 digit number, then we always get the remainder. Let me wipe out this, what I have written. Here we have the remainder is 0 if we subtract the original number with its reverse number and divide it by 9. The trick behind it is, let us choose any 3 digit number as ABC, thus 100A plus 10B plus C, and after reversing it we will get CBA, and which we can get in generalized form 100C plus 10B plus A, and their difference is going to be ABC minus CBA gives you 99 times of A minus C. Surely this is divisible by 99 because 99 is one of the factor. So, you know this 99 times of A minus C is divisible by 9 as well as divisible by 99. Okay. So, divisible by 99, here 99 is supposed to come and gives you quotient A minus C. This shows that remainder will always be 0 in any case of any number. Okay. So, we will try for the number 456. Let us look for the solution. Given number is 456, reverse number is 654, that is 654, and their difference is 198, and 198 is the product of 99 and 2. So, the quotient is 2. Okay. This 198 is divisible by 99, giving you remainder is 0. Okay. So, let us go for another important topic called forming 3 digit number with the given 3 digit numbers. So, forming 3 digit numbers with the given 3 digit numbers. Okay. If we have a 3 digit number, then we will always get the remainder 0 if we rearrange number in such a way that all 3 numbers are different, and if we add them all and then divide it by 37. Let me explain you with example. Okay. 3 digit number, here we are considering it as ABC, and its generalized form is 100A plus 10B plus C, and we rearranged numbers in such a way that it forms 2 different numbers. One number is BCA, another number is that BCA gives you CAB. Where is CAB? Here is the CAB. Okay. Now, BCA 100B plus 10C plus A, and CAB is 100C plus 10A plus B. So, we have got 3 digit numbers, 3 different of them, and we added them ABC, BCA and CAB. We added them. it gives 100A added to 10A added to 1A, so 111A. Similarly, 100B added to 10B added to 1B, so their sum is also 111B. So similarly 111C will also come. If I take out 111 as common, it gives 111 times of sum of digits ABC. Now by dividing the number by 37, we always get remainder 0. Why? Because 111, if you divide it by 37, you will get 3. This 37 3 times gives you 111. Remember, you know here 111 is having factors 3 and 37. So the number must be divisible by 37. Okay, we will try with some example. We are given 397. So 397 means I can form two other 3-digit numbers. One is 973, another is 739. So solutions of this, let us look for. Given number is 397 and we can form rearranging numbers 973 and 739. Just I am shifting 3 to this side gives 973, shifting 9 this side gives 739, that is it. Just gives the next number. Okay. So here I have got their sum giving us 111 times of sum of digits 19. Surely you will get. Here this 111 can be written as 37 3 times into sum of digits 9 plus 7 plus 3 or 3 plus 9 plus 7 gives 19. Okay. So here we have their sum 2109 being surely divisible by 37 and giving quotient as their product is 19 3s are 57 will come as a quotient. Okay. So 3 times the sum of the digits of a number will be as quotient. Okay, 3 times of A plus B plus C will come. That is how it is done. So children, another important topic we will do, revise, it is letters for digits. What is this letters for digits? I have so far discussed A, B, C. They are all letters used instead of numerals, where for a 2-digit number, where A being in tens place, B being in units place, we have used letters instead of digits. These A and B are digits. We said numerals. You know, numerals are any one out of 0 to 9, any one out of 0 to 9. Okay. So I am going to discuss the same thing. Letters for digits means in this type of puzzles, the letters represents the digits and we have to crack the code. Generally, it has puzzles related to addition and multiplication. Some important rules related to such type of puzzles will be very important and simple. Every letter can represent only one digit, that is it now. If I take AB, A is any one out of 0 to 9, it will not be at a time many. Next, vice versa also, one digit will occupy only one letter. Okay. Moving on to the another important rule, first digit cannot be 0, like 25 cannot be written as 025 or 0025. Okay. So first digit cannot be 0 is another important rule. Third rule, every puzzle has only one solution. Okay, one possible solution. For example, here find the value of P and Q. here is the question 1 to P. That means it is 120 to 129, any one number, correct na? This P can be any one digit from 0 to 9, any one digit, it can be any digit, understood? Similarly, this Q is also any one digit, right? Now, here solution, how we will solve this? Let us look for, you know, P plus Q is equal to 9, right? That means it is giving a some number ending with 9. Similarly, I have 2 plus P giving you a number ending with 0. It can be 10 or 20 or anything. Remember, P and Q are only one digit numbers. That means I have possibilities P being 0, then Q becomes 9, P becoming 1 means Q becomes 8, if P is 2 then Q is 7, if P is 5 then Q is 4 and so on. Now you have to look for a probable number or a digit suits P. Suppose I took P as 0, then 2 plus 0 cannot be 0, isn't it? 2 plus that digit should give ending with 0. So, I have possibility P being only single digit, 2 plus 8 gives you 10, isn't it? Therefore, P as P is a one digit number or one digit number, it can be 8, okay, it can be 8 as 2 plus 8 gives you 10 because it is ending with 0. Suppose if I want 2 plus 18 becoming 20 ending with 0, but P cannot be 18, P is not a double digit number, it is a single digit, isn't it? P can be any one digit number, okay. So, if P is 8, then here 8 plus Q equals to 9, it implies Q equals to 9 minus 8, it implies Q equals to 1, right. So, therefore, I got the value of P as well as Q. Then what is the result here? 128 added to 681 gives you, we have 9, 0 and 2 plus 8 is 10. So, 0 comes here and 1 is carry. So, 1 plus 6 plus 1 is 8. Therefore, we got 809, it exactly suits because P is 8. Here I have P means 8 is coming. So, therefore, P is 8 and Q is 1 suits exactly. This is how we think, right. So, how to write our thinking as a form of solution? Let me show you that. Okay. Now, I have wiped out all the written portions. Now, watch the solution. Here, solution is, here at once place the addition of P and Q is giving 9. It is given as 9. This shows that it is the sum of two single digits. As a sum of two single digits, numbers cannot be 19, hence there is not any carry in this step. For the next step, 2 plus b equals to 0. As there was not any carry from the last step, it is possible only if p is 8. This is the entire our thinking written in working steps or written in theoretical steps. Okay. Next, 2 plus 8 is 10, there 1 will be a carry for the next step. Therefore, 1 plus 1 plus 6 is equal to p, thus p is equals to 8. Clearly p is 8 and q can only be 1 to satisfy the given condition. Thus, the given question supposed to be 128 plus 681 is equals to 809. Hence, the value of p is 8 and q is 1. So, children, this is how we are going to solve questions of the exercise 16.1. I have already posted this chapter PDF in your respective WhatsApp groups. Look into the exercise 16.1. There are 10 questions. Try to solve like this question, and tomorrow's class we will discuss how to solve those questions. Okay. Whatever the doubts that you have got, you can get clarification with that discussion. Okay. Moving on to the today's end of the session. So, I will wind up now. Jai Hind. Thank you.